So as I said, I'll start us off with a discussion of the biologics R&D industry and some of the benefits of a solution like LabKey Biologics. And there's going to be a couple of points in time during this presentation where I'm going to invite some participation via poll. I'd love to have everyone chime in on that. I think it'll be fun, and I'll share those results at the end. I also invite any questions that you have about the industry or about LabKey Biologics itself, and I'll do my best at the end to answer any of those that arise. Okay, the biologics R&D involves very highly scientifically specialized teams, often in a transactional operating environment. A lot of give and take and passing things around. This often leads to a degree of data siloing, and it actually becomes an even greater problem when your institution is successful. If you transition from that laser-focused startup to one pursuing multiple research tracks or serving a wider variety of clients or expanding scope in other ways, the tools that work to keep you organized will quickly reveal their faults to you as you scale. It can become difficult to track the varied and changing data types of interest to you and integrate them without duplicating them. It also becomes much harder to coordinate those R&D efforts as you grow, particularly with those parallel work streams. And a great deal of effort can be required to hand data and conclusions off to other teams, as well as materials and plans and those such things, which is why we built LabKey Biologics. LabKey Biologics, from a high level, is a data centralization tool that helps to manage data across scientific teams to accelerate large molecule biologics development. Now, as you'll hear later, there are all kinds of varieties of R&D that LabKey Biologics toolkit can serve, but I want to start here. So there are many benefits of LabKey Biologics for R&D organizations looking to scale or become more efficient, and I want to highlight a few of those benefits. The first one is data centralization. Seemingly simple concept, but having one source of truth means that everyone knows where to put their data and in what form. They know where the reference data they need to complete their work can be found, and you can trust it because it's made it into that record. And they know where to find and aggregate data from for reports and regulatory filings and submissions to clients and stuff like that. The increased ease of finding data also means that there's much less duplicative work because you know what data exists for a set of samples or for a molecule or a cell line or whatever it is, and people across your institution are less likely to be unable to find it and have to reproduce it. LabKey Biologics also improves collaboration efficiency. Having tools for managing and prioritizing requests and centralized data for easy handoffs across teams can dramatically reduce the effort required to stay synchronized. I've told stories in the past of organizations that have to very regularly generate internal presentations just to stay in sync and have very regular meetings just to make sure that everyone remains on the same page. And these collaboration efficiency tools and centralization can really reduce that effort. And there's tracking samples. There's, of course, data that has to be made available to other people, but also the materials that you're working with and information about those samples. And tools that help you characterize and track the state and locations of your samples are really invaluable as you scale. LabKey Biologics also helps to accelerate many of your operations. So every operation, of course, has its pain points, but there is a great deal that can be automated from creating data structures and controlling permissions, to importing files and connecting to related data. Little things like templates and notifications can also really speed things up. And all of these things become faster when they are obtained within a single application. And the last benefit I want to highlight is ease of extracting insights from your data. We know much effort can be required to stitch together the data required to answer scientific questions. In fact, yesterday, you heard some of that directly from Katie Hughes at INZEN. By providing ways for you to view your related data together, as well as providing ways for you to connect your data, it becomes much easier to do the types of analyses and visualization creation that are necessary for advancement. And we really want to meet institutions where they are as well. And so we try to make it easy for you to either extract that integrated data or to make use of it through our APIs, as well as integrations, such as Spotfire, Tableau, and other popular tools for the same purpose. So next, I want to highlight some of the key feature areas of LabKey Biologics and walk through how they provide some of those benefits that I just mentioned. First, I'm going to highlight our electronic laboratory notebook, which allows scientists to efficiently document their work because of its integration with LabKey Biologics structured data. Then I'll touch on our bioregistry, where you can capture reference data for a variety of biological entities. Many of the common biological entities are built into the product, but others can be easily added as needed by your institution. Then there's the very practical sample management area. Here, samples of relevant types can be registered along with their metadata and used in workflows. Parent-child relationships between samples are maintained, and that's particularly important for biologics R&D exploration and analysis, is to understand the lineage and what has happened to a set of samples as it's gone through the pipeline. Then I'll touch on assay results integration with those samples, which of course provide the backbone for the characterization of a particular molecule or cell line, for example, that may be the core of your R&D. There's media registration, which is an area that supports, for example, cell media development by allowing registration of media components and the variations of their combination for use in cell growth. And then my last point is going to be about workflow management, which is the collaborative mechanism in LabKey Biologics to help coordinate the contributions from multiple people and teams. So here is where I'm going to take my first very brief pause and ask to hear from you. I realize I haven't taken a deep dive in any of those areas yet, but given what you know of the listed feature areas, I'd be very interested in knowing from your perspective, what would be most beneficial to your operations? And later on in my presentation, I'm going to try to take a minute and share the poll results. So yeah, jump in. Love to hear from you. Okay, while you're responding to that, let me get started with a slightly deeper dive. So for those of you that attended last year, this will be of no surprise to you, but our latest major addition to LabKey Biologics is our ELN. It uses a I think fairly unique and very powerful paradigm to harness the long-term value of a structured data model. It is built on top of the other components and data types that I mentioned. Our ELN centralizes your documentation with your data, and authors can simply reference existing data from LabKey Biologics straight into the notebook. This means your data capture actions, whether they're automated or manual, serve everyone. From your wet lab scientists in their analysis and documentation, to the data scientists or bioinformaticians that are doing additional analyses or modeling. It also serves the IT teams that are tasked with security and backing up data to have it all in a single location, and management in an organization looking for progress and critical reports. We also built this ELN specifically with collaboration and efficiency in mind, because speed in biologics R&D is definitely the name of the game. And one of the biggest gains in both of those categories is something very simple: the use of templates. Commonly repeated work can become a fill-in-the-blank operation, and in fact, guidance for others can be placed in those templates so that notebook standards can be encouraged. For work that multiple scientists contribute to, which of course is most of it, you can simply co-author a single notebook. There's really no reason to compile multiple notebooks, 4 scientists contributing, 4 notebooks created. There's no need to have to stitch those together after the fact, or review all 4 of those. There's also a mechanism to discuss entries within the notebook itself. These conversations, this commenting can be very useful between co-authors, but also for communication between reviewers and authors. We also made it easy to find your notebooks and the notebooks awaiting your review. Those submissions, as well as the comments and the various discussions that you may be involved in, can provide an email notification so that they don't get stale. And we can get everything signed, sealed, and delivered more quickly. And of course, once those notebooks are completed, they can be downloaded as PDFs if that's useful for your institution. They are, of course, explorable within the application, and you can click through the referenced data in your notebooks to get a full view of what that data looks like in the system. And we've also provided a way to export all of that referenced data in a given notebook for easy sharing, in an attempt to make that useful to other parties that are examining the work that you've done. Okay. Next is our bioregistry. The bioregistry centralizes reference data to accelerate finding information, to standardize that information, to prevent duplicative work, as I mentioned before, and to assist with extracting insights from that data. We do this by providing structured data capture for related biological entities. These Platonic concepts and their metadata are connected and made available for reference, for examination, as they are manifested as real samples in the system. So I have a set of samples that I'm working with, and you see those registered samples in the system, and within the details of those samples, you can see those biological entities that they came from. And I have a few concrete examples listed here that I'm going to use to try to help clarify that. So you can register sequences individually in bulk. That's nucleotide and protein sequences. We prevent duplicative sequences from being entered to make sure that your characterization of those sequences, your use of those sequences, doesn't get split into 2 different areas. And we allow you to annotate those sequences. We will also automatically annotate the recognized sequence sections that are recognized by the classification engine that we use. Nucleotide sequences can be translated into protein sequences, based on your selected reading frame, which in turn can be used to construct various molecules of differing stoichiometries. Variations in those molecules are stored as sets, and we provide a number of physical property calculations on those registered molecules for your reference as you work. So when you produce a sample, you can have it connected to those concepts, to a particular molecule, since, of course, in the example that I just kind of described, that's what I was referring to. You can imagine it being an antibody or something like that. And of course, in your real world sample, there's a lot more in there than just the antibody. But the important information is which of those Platonic concepts are contained within the sample. And we make it really easy for you to look at what is in that sample. There's also a place to register the cell lines you develop and the vectors and constructs that you may transfect into them. And those produce unique expression systems, which can be captured as well. On each of these different bioregistry entities that I mentioned, you can capture all kinds of metadata about them. There's plenty of information that we capture by default, but of course you can add additional information that's relevant to your institution. As I mentioned before, the relationship between all those entities and their unique combination are maintained by LabKey Biologics for later exploration and analysis. And while I mentioned a couple of those common types, the various sequences and cell lines, et cetera, you can easily add more types that are relevant for your R&D. Okay, so let's get practical here. Sample management. So our sample management features allow institutions to centrally register and track samples of any type along with their relationships to each other. So before I mentioned lineage, that parent-child relationship, and that's a really important concept in sample management in LabKey Biologics. This all means that collaborating teams can easily ascertain the state of existing samples, whether they exist, what data exists for them, and explore any lineage relationships that exist between them, both graphically and in the data itself. We empower your administrators to add sample types and metadata as your work evolves. So as you grow, as you scale, and as you are dealing with new types of samples, connecting those with your existing architecture is easy. I'm particularly excited about our freezer management capabilities being in LabKey Biologics now, since it really enriches the solution with more critical sample information, things like freeze thaw counts and quantities, for example. It also introduces the ability to visually manage freezer capacities, as well as location availability, which all very nicely rounds out LabKey Biologics by consolidating more relevant sample information into one place. Now, when you are examining those samples, you can also see what assay data has been captured for them. That works and is exemplified quite nicely with our improved aliquot support in LabKey Biologics. When you derive aliquots instead of child samples in general, all that sample metadata from the parent that you've captured is pulled down and distributed to each of the aliquots that are generated. And so you can see it on the aliquot itself. And when you import assay data for those aliquots, which is the common operation, since those aliquots are so often used up for different assays, we roll that assay data up to the parent seamlessly. So it really nicely maps to the realities in lab. Speaking of assays, LabKey Biologics serves as a central assay data management hub for everything from simple chemical and physical measurements to more complicated instrument data. It allows integration with sophisticated analytical software, things like Empower or Chameleon that your analytical chemists are going to be playing with a lot, and can be configured to automatically consume file outputs for alignment with registered samples in one centralized and secured system. Our assay architecture scales well, which is something that people ask us about on the regular. We have users with hundreds of thousands of assay runs across multiple dozens of assay types, and I get asked pretty regularly as part of supporting some of these organizations, how long will it take me to establish these assay types or a new one? And it's really quite easy. I think often the question arises from some assumption that there's a very complicated analysis required to design the assays. But it's really quite easy. You can infer the fields that you wish to capture from an example result file, and our support team can quickly show you how to configure connections to other data in the system. There are also all kinds of useful and fun settings to add. Things like out of range indicators on fields, conditional formatting to and image attachment. So of course, many of your results as they come in, there are associated images, snapshots or files that are relevant to those results. And your administrators are empowered to do this again on a whim as needed. It just takes a few minutes. So assay results can also include time components for your operations, where that is important for decision making. This is common when samples are generated from different time points. You can also automate data import through a variety of mechanisms. The most common one probably being file watchers. So results come off a machine in the form of a file, and LabKey is listening for those files with a certain name convention. We then pick up that file and, as an example, move it somewhere else and import the data into those assay designs. We even support custom import pipelines for more complex scenarios. There are also a variety of ways to ensure quality of your data, to prevent bad data from being incorporated into your record. Those include QC statuses, which can prevent data from becoming visible to others until approved, special parsing and transformation capabilities to clean, reformat your data, and even calculate additional values. And of course, once the data is in, the assay runs are visible in connection with those samples, as well as in aggregate with other runs of the same type, and for individual workflows to enable you to do the analysis you need. And as I mentioned before, we make working with third-party analysis and visualization software quite easy. So worth mentioning is our media registration area, where you can centralize details about the many components of media development. You can register the particulars of a given mixture or recipe. The available batches of those media can be used alongside expression systems, for example, to keep track of how certain samples in the system have been generated, and enable you to look back at what led to the results of a particular set of experiments. We also allow you to capture a great deal of detail on the ingredients themselves, as well as the batch metadata. Okay, and finally, I want to talk about our workflow manager. So while LabKey Biologics provides, I think, some fairly enduring value through this powerful centralized structured data architecture, a bench scientist might not recognize their daily operations in the architecture itself. Our workflow manager is the primary explicit collaboration tool in LabKey Biologics, and it provides the narrative arc for scientists, for scientific operations, guiding work progression, expectation setting, data capture, and project state. So the LabKey Biologics Workflow Manager allows you to explore ongoing work that's pertinent to you and affect the requested timing and priority of work of interest. Practically speaking, you can initiate jobs containing a set of tasks to be performed. Each can be performed by a different assignee or all by you. And that cooperation can be facilitated by individual notifications. This is also the mechanism for process modeling in LabKey Biologics. We've made those workflow tasks parameterizable, meaning you can capture the conditions for each step and view the gathered results for the workflow. To further accelerate the work and standardize where possible, these workflows and parameters can be templatized, similarly to the way I described it for our ELN. Okay, here's round two. I would love to hear from you on this poll regarding workflow. At your institution or lab, how do you manage requests? How do you manage workflows? Is this something that is all in meetings, or is it in files in Google Drive? Do you have a standalone system for this, or do you have something that's integrated with your data management? Very interested in hearing how this works for people. All right, in summary, we have a powerful set of flexible tools designed to provide some core benefits to institutions looking to accelerate or scale their R&D. That's everything from our ELN to the structured data capture of our bioregistry, workflow management, and integrated assay and instrument data. We aim to truly partner with our clients, and I invite you to share with us what kind of challenges you face, and to stick around for our next speakers to hear a little bit about what partnering with us is like. And it looks like I got some great results here for the poll, and I wanted to just briefly try to share some of that. Let's see. Okay, it looks like literally half the attendees use spreadsheets and emails in order to manage workflows, with a few in each of the other categories. That's really interesting. And then I guess I could just share the results. I'm sorry. I am having a little bit of trouble pulling up the information for our first poll. I may have to share that a little bit later. Oh, wait, here we go. I got it. Okay. Actually, it looks like there's a pretty good distribution for interest in the feature areas. Looks like there's a lot of interest in sample management and assay integration, as well as ELN and workflow management. Very cool. Okay, thank you so much. I'm interested in if there are any questions. I'd be happy to take those now. Looks like there is a bit of a question about how biologics relates to LabKey Server, which you heard Adam talk about yesterday, as well as LabKey Sample Manager, which you're going to hear about tomorrow. Yeah, great question. So as Adam mentioned yesterday, for those of you who had the pleasure of hearing from him, LabKey Biologics and LabKey Sample Manager are built on the LabKey Server platform. And so they share an architecture, but they are oriented towards very, very different purposes. LabKey Biologics is of course specifically oriented towards biologics R&D. And as you'll hear from Hannah tomorrow, Sample Manager is specifically oriented towards sample management at various size labs. They share some core similarities in that, excuse me, in that they, I mean, you heard me talk about sample management in LabKey Biologics. Those are parallel experiences within Sample Manager, but LabKey Biologics has a few other distinguishing features about it that make it more biologics R&D oriented, many of which I referred to today. Looks like we have a couple of other questions in. Questions about freezer management. Yes, so I mentioned freezer management in biologics. It is now in LabKey Biologics as well as in Sample Manager. Cool. And we'd love to show you how that works in LabKey Biologics. So if you have some interest in seeing that and understanding how that works, please get in touch with us and let's have that conversation.